You don't have to have heard of vectors before to talk about to be in this class. I'm going to assume you do not know them. I'm going to talk about what the vector space Rn is. This is the set of n tuples of real numbers. So, for instance, if you look at 1 to pi, that would be an element of R3. Or if you look at 3.1, 2.1, -5, 0, that would be an element of R4. This is what's called a vector space. And these things are called. Now, for our purposes, we're going to say that there are 4 important things that you can do with vectors. Thing 0, the word vector just sounds cool, but we're not going to put that as one of our things. First thing is you can add them. So if you have 2 vectors, if you have 1, 5, 6, and you have also you have to do something to indicate you're working with a vector. I like to use arrow. So if I have x equals 1, 5, 6 and y equals 2, -3, 7, I can calculate x plus y, which is going to be 1 plus 2, 5 plus -3, 6 plus 7. So we're going to be 3, -2, 13. It works the way you might hope. You just add them all together all at once. Two, thank you very much. The second thing you can do is you can scale them, which is multiplying them by a number. I can multiply a scalar times a vector. If I look at 3, I'm going to use the same x I have up here. And I have 3 times 1, 5, 6, which will be 3 times 1, 3 times 5, 3 times 6, 3, 15, 18. You may also hear this called scalar multiplication. But the idea is you are lengthening or shrinking them. The third thing you can do is you can take distance between them or take the inner product, which is their related ideas. Let's start by talking about the inner product. So if you have the inner product of x with y, what you're going to do is multiply the first components of the vectors plus the second components of the vectors, and you keep doing this until you have the last components of the vectors. So if you're familiar with summation notation, it would look like this. So for example, if we have our x and our y over there, in that particular case, we would have 1 times 2 plus 5 times -3 plus 6 times 7. Why is this important? This is what enables you to define the notion of an angle. This tells you how much in the same direction. Two multidimensional things, which we're going to start doing today. I'm going to often use 2 dimensions because I can draw 2 dimensions. When you create a 4-dimensional virtual reality simulator that I can draw in, I'll use that. But 2 dimensions is good enough to get the idea. And the final thing that we can do is we can define functions that take vectors as input. That I would say this, I would write it such a function as going from Rn to R. R to the n, that vector space is the domain, and R is the codomain. So we can define functions that take vectors as input and return numbers. And an example of what this might look like is I could define smiley face to go from R cubed to R. I could define smiley face of x1, x2, x3 to be equal to x1 squared plus x2 times x3. And then I would just evaluate this for 1, 4, -2, give me 1 squared plus 4 times -2. It works exactly the way as evaluating a function that only has one input variable. It's just that now you have a bunch of variables to keep track of and to do algebra with.